Assalamu alaikum. In today's session, we will start exercise 4.3a of IGCSE Extended Mathematics that is recommended by AQA examinations. Our topic is frequency diagrams. Before moving to the questions, we will first discuss some terms that are class width and frequency density. Basically, when in our previous exercise like 4.3s, where the class width was same, means the class interval was same, so we were not considering frequency density. But here we will see that what is class width and how the frequency density appears if the class width is not same. So look, class width is basically the difference of the upper boundary and the lower boundary. Like, like we make class intervals in the frequency diagrams or in frequency data. So in this class interval, you can see that this data is from 130 to 140, then 140 to 150, and then 150 to 160. So if you see the difference between the upper and the lower value or upper and the lower limit, you see that class width remains 10. So for this type of data, if it is discrete or continuous, we can simply make the frequency diagrams or histograms or bar charts. But what about if the class width does not remain same? For example, in the next example, you can see that the class width is not same. This first interval is from 0 to 10, then 10 to 30, and then 30 to 45. So the class width is being changed. Like the first class width is 10, then 20, then 15, and then again 15. So when the class width does not remain same, we consider frequency density to draw the graph. Like the height of the graph depends on frequency density instead of frequency. So how do we find the frequency density? For the frequency density, you actually divide the frequency of particular class interval by class width. Like here in the first case, if the frequency is 5 and class width is 10, so if we divide 5 by 10, we get 0.5. So the height of the bar will be 0.5. Similarly, in the next interval, the class width is 20 and the frequency is 12. So if you divide 12 by 20, you get 0.6. It means the height of the bar or the height of the histogram should be 0.6 in this interval. And similarly, we can see the next values. So in short, if I revise this thing, that if the class width remains same, we can simply plot the bar chart or the frequency diagram by considering the frequency for the height of the bars. But if the class width does not remain same, we will consider the frequency density for the height of the bars. So if you have equal class widths, we will use the frequency as the height. But for unequal class widths, we will consider frequency density for the height. Now let's proceed to questions. In question number 1, it says that we have to copy and complete the table, and then we have to draw the histogram to represent the data. So first of all, look, we have to complete the row of class width. And class width is definitely the difference of the upper boundary and the lower boundary. So here the class width will be 2. And here the class width will be 1, and 1 again, and then again 1, and then the class width will be 3. So look, in this data, the class width is not same, so we will consider frequency density for the height of the bars. And for the frequency density, we know that we divide frequency with the class width. So in the first case, if you divide the frequency by the class width, we get 6. In the next one, we get 17, and then we will get 19, then 11, and then 6, because 18 divided by 3 is 6. Now let's plot the histogram. By the way, we can also see that this data is continuous, so that's why we are making histogram for it. On the other hand, if the data will be discrete, we will use bar charts to represent frequencies. So let's make the frequency diagram, means histogram. For the histogram, we know that the labels means x-axis label and y-axis label is mandatory. So on x-axis, I have represented the time, and you can carefully observe that I have used the square bracket here, means 1 is included in this interval, and small bracket here means 3 is not included in this interval. And similarly, 3 is included in the next interval, but 4 is not included. So please observe the brackets for clear understanding. And similarly, here is the frequency on y-axis. And I have also given the title to this graph, which is the reaction time of sample of students. So now, as we already discussed that for the height of the bar, we will consider the frequency density instead of frequency, because in this data, the class width is not constant. So look that the height of the first bar should be 6 because the frequency density is 6, then 17, then 19, then 11, and then 6. Now let's proceed to next question. In next question, I will not completely do this, but I can just give the overview that here the class width will be 5, then 5, and then the class width will be 10. And for the next interval, the class width will be 20. Means, again, we don't have constant class width, so we will consider the frequency density to draw the histograms. So I'm leaving this question for you. You can easily plot the graph for it. I'm moving towards next question. In next question, again, we have to draw the histogram of times dog owners spend on daily walks. So let's consider the class width first. Here the class width will be 10 because 20 minus 10 is 10. Then class width will be 20, then 20, and then it will be 30. And here we don't know the class width over here. Now we know that for the frequency density, we use this formula. Frequency density, we divide the frequency by the class width. So for the first interval, the frequency density should be 8 divided by 10, means 0.8. So here, the frequency density will be 0.8. But in the next column, we are already given with the frequency density and we don't know the frequency over here. So we will use the same formula to figure out the frequency here. Means we will just multiply the frequency density with class width to find frequency. We just rearranged this formula. So the frequency will be equals to 0.8 times the class width, which is 20. So here we get 16. So we will mention 16 over here. Similarly, in the next frequency, we again have to multiply the class width and frequency density to get the frequency. Similarly, again in this unknown block, we have to multiply the class width with frequency density. So 20 times 1, 4 will be 28, means the frequency was 28 over here. Again, we need to multiply 1.3 with 30, and that is 39. And for the last column, we know the class width and we know the frequency, but we don't know the frequency density. So we will again use the same formula, means for frequency density, we will divide the frequency by the class width. So we will divide 9 by 30, that is 0.3. It means the frequency density is 0.3. Look, we also don't know about the upper boundary of this data, but we know the class width, which is 30. It means the difference of the upper boundary and the lower boundary is 30. So the upper boundary should be 120 over here, because if you subtract 90 from 120, we get 30. Now let's plot the histogram. For histogram, again, we need to give the labels, means x-axis and y-axis, and also we need to give the title. So on x-axis, look, the time is mentioned, and you can observe that I have put the square bracket here because 10 was included in the first interval while 20 was not included in the first interval. So I have used the small bracket. And on y-axis, there is frequency, and also the histogram will be given a title, which is times dog owners spent on daily walks. So let's plot the bars. We consider the frequency density for the height in case of unequal class width. So look that it is on 0.8. Then again it's 0.8, then 1.4, then 1.3, and then it's 0.3. Now let's proceed to next question. In question number 4, it says the histogram shows the times a sample of students spent watching TV one evening. In A part, it says how many students spent longer than 2.5 hours watching TV. So we are given with the number of hours in the x-axis, and on y-axis, it's mentioned frequency density. So we know that for unequal class width, we use frequency density. So to get the number of students who spent longer than 2.5 hours in watching TV, we need to use this formula. That the formula says the frequency density is equal to frequency divided by the class width. So to get the frequency of the number of students who spend more than 2.5 hours, we multiply the class width with frequency density. So the class width in this interval is 0.5 and the frequency density is 20. So 0.5 times 20 is definitely 10. It means there are total 10 students who spent more than 2.5 hours. In B part, they want us to complete the table, means we need to find the frequencies. We are already given with the frequency density and the class width. So again, for the frequencies, we multiply the frequency density with the class width. So first of all, we can mention the frequency density for each bar over here. Like in this interval, the frequency density is 8. And in this interval, the frequency density is 36. Then it's 52. Then it's 40, and then it's 20. So we can just multiply the frequency density with the class width to get the frequency over here. Here the class width is 0.5, means the difference of the upper and the lower boundary is 0.5. So we will multiply 0.5 with 8, that is 4. And similarly, again, we have class width 0.5, so 0.5 times 36 is 18. And then the class width is 1, so 1 times 52 is 52. And then the class width is again 0.5. 0.5 times 40 is 20. And then 0.5 times 20 is 10. So how many students were in the sample? So we have to add all these frequencies to get the total number of students. And that is 104. Now let's proceed to the next question. In question number 5, it says the incomplete table and histogram gives some information about the masses in grams of sample of apples. Use the information in the histogram to work out the missing frequencies in the table. In A part, they want us to use the information in the histogram to work out the missing frequency in the table. So let's observe the table. In the table on y-axis, there must be frequency density because this is the histogram for the unequal class width. So in the first interval where the class width is 20, we can easily find the frequency density by dividing the frequency by the class width. So the frequency is 8 and the class width is 20. So if we divide 8 by 20, we get 0.4. It means that this height is 0.4. And similarly, for the next interval where the class width is 10, means from 140 to 150, we can easily find the frequency density again by dividing the frequency, which is 6, by 10. So here the frequency density is 0.6. It means that this height represents 0.6. Now from this data, we can easily get the idea of the frequency density for the next interval. Here the frequency density can be considered as 1.2. While the class width here is just 5, so we can easily find the frequency, means the missing value over here, by multiplying the frequency density with the class width. So 1.2 times 5 is 6. Similarly, for this one, we can consider the value as 3, means the frequency density is 3 over here, and its class width is again 5. So if we multiply the class width with the frequency density, we get 15. Then for the next class interval, which is from 160 to 165, where the class width is again 5, and we can consider this frequency density as 3.7. So 3.7 times 5 is 17.5. So this is how we can complete the data, because for the frequencies, we just multiply the frequency density with the class width. Now let's do the B part where we have to complete the histogram. And for the histogram missing bars, we will consider these 3 intervals. This interval is, let's suppose, the first interval, then second interval, and then third interval. And in the first interval, where the class width is 10 and frequency is 16, we can easily divide the frequency by class width to get the frequency density. And frequency density will be definitely 16 divided by 10, that is 1.6. So let's make a bar where the height will be 1.6. So for the next interval, like from 160 to 175, its height will be 1.6. Now let's make the of the next interval. In the second one, where the class width is again 10 and the frequency is 12, means the frequency density will be 1.2. Let's make the bar for the next interval, and it will be just 1.2. Then in the last interval, where the class width is 15 and frequency is 6, if we divide 6 by class width 15, we get 0.4. It means the frequency density will be 0.4 in the last interval. So let's make a bar over here. That will be just about 0.4. So this is how we can complete the unknown data in the table, and we can plot the frequency diagram, means histogram. This was all for today. You can ask your questions through comments. Thank you.